We're going to try another problem that involves functions of time, but in this case it involves integration, a calculus 2 concept. This is a problem that students usually stumble over as I've been teaching this class. And so what I've done is I've actually combined two problems in one. You notice this one actually has two given, solving for time and that. And hopefully you'll find this video helpful to you. So let's get right into it. Notice I have a typo right here. But let's see what else we are given. First things first, trying to understand what are we doing. And we're given that at time equals 0, car's velocity is 16 meters per second. So that is actually our initial velocity. We'll need that later. And we're given that acceleration is a function of time that is negative. Okay, so pretty much this is a linear equation, as you can see, and that we're supposed to show our goals as twofold, that it stops at t equal 8 seconds and it has traveled a distance, its displacement rather, is 85 meters. Okay? Our formulas that we'll be needing do involve integration. Write them both down. And now it's a little bit different. I added this part into it, and if you take a look at these real quickly, you notice that this is just simply delta v. It's a delta. And this is just delta x. Okay? So it looks a bit harrowing, but it's actually a straightforward integration problem, and you can look it up. You can learn it even in an hour, I think. So here's our solution. Okay, so from our acceleration function, keep in mind what we're trying to find. We're trying to find the time and when velocity is 0, so we need to solve for velocity. So we need to plug that acceleration into here. So what I'm really just doing is plugging this right there. And you'll notice that this is actually constant, so it's not changing with time. I can take it out. And that gives us the integral of t dt, and we're actually going to put limits on this from 0 to t. Okay? Makes it kind of intuitive. And becomes t squared over 2 from 0 to t. Now take note, I can change this 0.5 also into 1/2 as well, and then what I'm going to get is negative t squared over 4 minus a negative 0 4. Well, actually we don't even need that part at all. Okay, now we still have this on the other side, so I'm going to actually add the initial velocity to both sides, so that will cancel out. Okay, which gives us another function. Plus, and the initial velocity was actually 16. meters per second. Okay, so we'll come back to this later, but we need to just apply the same exact process, really, a little bit different, to a different formula, different formula, plugging this right into there. But now I have two terms, but it's actually still not that bad. I promise you. I'm not going to write the units this time. Now take note, there's two terms here, that and that. So I can actually split them as per your rules for integration. One step at a time. Oh, check that out. There's not even a t there. Once again, I am going to, this is actually like -1/4. I'm going to bring that out. T squared dt plus 16 integral dt. Now this would just result in t. Okay, this results in t cubed over 3, once again from 0 to t. Plus 16 t, once again from 0 to t. Might as well not even put that 0 there. I can just keep it like this, really. Okay? And once again, this is actually delta x. And so we can actually solve for delta x first, almost. Let's do it in order. So go to page 2 and rewrite these equations that we had. One for velocity, and we had another one for okay. So here I am going to, we need to find what time is velocity equal to 0. So we need to set this to 0, t squared over 4 plus 16. Okay, and then what I'm going to do is I'm going to multiply all that by 4, so that will cancel out. 4 times 0 is going to be 0 still. Mixing up my colors. And that's going to be actually 64. It doesn't actually show, but now what I've just done is just turned all of this into the units here actually in seconds squared. If I know that, you'll find out in a second. I'm going to add t squared to both sides. That will cancel out. And I get t squared equals to 64 seconds squared. Square root of that, I get t equals 8.0 seconds. Right? I actually get two answers out of that. This is plus t negative 8.0 seconds. Time is actually scalar, so that actually does not make sense. We're just going to use this. Okay, and that is the first of our answers. Okay, and I'm actually going to do something similar here. Just plug in 8 seconds and just find out how far it went. Essentially, this delta x is still kind of like a delta xt, but now delta x in 8.0. So that is negative 8 cube 12 plus 16 times 8. Now, once again, since this is in displacement, the units here should come out to be meters. Remember, we can only add or subtract things that are the same. Okay, I had to work on my calculator for a little bit. This ends up being negative like 42.7. It's 128 meters. And you're going to get something close to 85. How many significant figures were given? It was all 2. So it's 85 meters. It's meters. It's 85.33333, but we're going to stop right there. And sure, that's it. So take note how we use integration, but a lot of it was just simple algebraic skills and then just a little knowledge on how to do some basic antiderivatives or integration. Okay, good luck, enjoy.